Thank you guys so much for coming to this episode of Trace Talks. And today we're going to dive into everything that you guys do at Quilter AI. And I want to hear first about your backgrounds. So please introduce yourself and tell me why you deserve a seat at this table. Okay, yeah, I'm kidding a little bit, but go ahead.
Well, thank you for having us. It's
Yes.
great to be here. So my name is Sergiy. I'm the CEO and founder of Quilter. A bit of background before starting this company, 4 or 5 years ago, I was an avionics engineer at SpaceX and dealt with designing boards and subsystems of electronics of all kinds, and wanted to make the process a little bit smoother, and hence why we're here today.
Great.
Yeah, I'm Ben Jordan. I've known you, Amit, for quite a while in Sierra.
Yes.
I am a kind of EDA veteran, been at Altium, been at Autodesk. I'm an electronics engineer as a background. I've done a lot of design as well. Nothing quite as cool as what Sergiy's done, or glamorous, let's say. But I saw what Quilter AI was doing last year, doing research on new startups in this space. And it's just a kind of funny story. I felt really bad because I shared this with someone over lunch today. In 2018, I wrote an article that was published in Design News or one of those publications about, I think it's time for AI and PCB routing. And it was actually going back to the auto routers that actually have their roots in the 90s were actually machine learning based algorithms. The problem was they were using variations of supervised learning, and they did not have nearly large enough training data sets, and they did not have nearly enough compute. The idea was good, but anyone who's tried an auto router in a traditional CAD tool in the last 30 years has played with it and then used it for other things, but not actually routing.
Makes sense.
But when I started seeing, all the GPU, the compute capability ramping up, and I wrote that article in 2018 and just discussing my opinion on that. What's funny is during COVID, I was on summer vacation. Unbeknownst to me, Sergiy was reaching out to me on LinkedIn, and I hadn't been on LinkedIn in months, so I didn't even notice his message saying basically, I read this article you wrote and it really resonated with me and I'd love to discuss some of this with you. That went ignored or unnoticed for 2 more years.
Oh, geez.
And then at the beginning of 2024, like that was probably 2022 actually,
Yep.
that you sent me that message. So my timing was a bit off there. But so 2 years later, I'm on a consulting call with a consulting firm about AI startups in PCB design and what do I think about all these different companies coming up. Some of them I knew, some of them I didn't, and I was doing my own research. And I found Quilter, found Sergiy, and realized they were hiring for a staff electrical engineer. And I'm like, I have got to get behind this. Like,
Nice.
It's now or never. This is a turning point in our industry.
It is.
And somebody's going to do this. I want to be involved. And then I had the embarrassing task of going on LinkedIn and finding out who are the guys running this, who is Sergiy, what's he about? And I'm like, crap, he reached out to me 2 years ago and I never replied. So I'm like, I'm really sorry, dude, but I love what you're doing and I actually want to get behind it. So here I am.
That's awesome. Timing is everything.
Yeah.
And check your LinkedIn.
I mean, hey, when you pursue great candidates, it takes a couple of years to convince them.
It does.
That's fine.
It does. It absolutely does. Well, that's great. We have a lot to talk about. I have my own curiosity as well. But I want to start with like a couple of hard questions for you, Sergiy, if that's okay.
Sure.
So there are big behemoths, you could say, in the industry, EDA tools, and they all have an AI strategy, right? So first question, how do you see yourself competing with other big behemoths who claim and actually do already have an AI, let's say, rollout end strategy? Why do we need Quilter?
Yeah, that's a great question. I love that question. I mean, I think there's kind of two answers to this, right?
Sure.
One specific to our industry, but one just general about startups, right? Like if you follow the logic of, hey, big company has this thing, startup is making this thing, startup's never going to make it. Well, history disproves that over and over and over again, right? You look at Dropbox versus Google Drive and, Google Photos and all these kinds of things. It ends up happening, right? And there's books and books and books on the topic around the innovator's dilemma, around the ways that these big companies are, locked into their pricing models or locked into some old way of thinking about things and are disincentivized against inventing something new because they have to first invent their old thing out of existence to make the new thing possible. But more specific to our industry is kind of the more relevant question, right? And in my opinion, like, the most important question to ask is, you go on the floor of like my old job, right, SpaceX, or you go to Tesla or to Apple or to Google or to, any of these hardware companies, and you ask the PCB designers and you say, are you using any automation right now? Like, what are you doing today to design a board? And they're not, right? So the way I see it is nobody's captured this market yet, right? Nobody's solved it. It's all up for grabs. So how do we compete with these big companies? I mean, we have to get first to these customers and give them something that they can actually start to use. And certainly AI is kind of a very broad term. There's a lot of ways to go about it. And we have a lot of opinions about how to solve this problem that we are taking that our competitors are not taking. So happy to dive into those.
I mean, yes, please, because if I'm not convinced, then how can the audience be convinced?
All right. All right.
So, I hear what you're saying. Yes, startups come with a different mentality sometimes. So that is definitely an advantage for a startup. And they don't have old ways of thinking they have to overcome. Fully agree with that. You kind of mentioned something that I do want to dive into a little bit, which is, you have this way of thinking about the problem. You kind of touched on it. How is that different from how a Cadence or, these other people, Altium, I guess, who are approaching AI as well? How is Quilter different in the thought process?
Sure. So there's two key things in my opinion, and for what it's worth, like, it's not like I have somebody at Cadence telling me exactly what their strategy is. Like, I don't want to speak to anything of that, right?
Yeah.
I know what we do. I know what they advertise, but that's all.
Sure, of course.
But there's a couple of things that are important that are different, right? So one opinion that we have is about how to approach the problem.
Sure.
Okay. So, and the way that we approach this problem from a technical perspective is with the field of AI called reinforcement learning. So the difference here is, like, a lot of AI applications today are done with what's called supervised learning, right? So this is, for example, how ChatGPT was trained. And the idea is you show it a bunch of examples of, if I give you this input, here is the output that a human would produce. And so please just do that, right? So in the context of language for ChatGPT, it's, let's take however much language there is on the internet, taking Wikipedia and Reddit and all these different sources, and give it a paragraph of what a human said and predict what the human was about to say. And the language model just predicts exactly that, right? So this is called supervised learning. And in PCB design, that would, it would make sense on the surface, right? Like, you show a AI, like, here's the schematic, here is the layout that a human produced, do that, right? And repeat that a bunch of times. And now the approach that we take is not quite like that. We don't train on human data at all, right? So the belief that we have is that the signal for what is a good layout and what is a bad layout should come from physics and not from human data, right? So and this is, like, ChatGPT is the famous example of a supervised learning model. AlphaGo would be the famous example of a reinforcement learned model that became superhuman at playing the game of Go. So the idea is, okay, start with a neural network that doesn't know how to do a board layout. Let it try billions of times, billions and billions and billions of times. And every time it tries, run physics simulations on it and tell it, did it do well against manufacturing, against signal integrity, power integrity, so on and so forth, or did it not do well? And then based on that signal, when it does well, tell it to keep doing that. When it doesn't do well, tell it not to do that. And what that opens up is it opens up the path towards designs that are better than any human could potentially make. And again, without human input. So that's one kind of like big opinion that we take that is uncommon in this industry, I would say. The other one is about how we position the product, right? So for most vendors that sell a license, the key thing you want to do is to keep people using that tool with that license, keep buying that license, right? Keep buying that seat. So what you end up selling is a co-pilot. Like, hey, I will take you as a designer and help you get stuff done faster with a bunch of bells and whistles that help you, place faster, route faster, whatever else. We don't take that approach either, right? So instead of taking some fraction of a designer's time and saying, we'll go from helping you save 10% of your time to 20 to 30, what we're doing is we're saying, hey, out of all the boards you might design, we're going to design the ones that we can end to end. So maybe there's 10% of boards that we can handle end to end that are going to be designed in a way that, will work well once manufactured. But those are designed end to end. So you don't have to spend your own time kind of working on them. You give those to Quilter completely. Quilter works end to end. And then for the boards that we can't do, okay, that's still on humans. So the idea is to focus on complete automation and then grow the fraction of the boards that we can actually successfully complete with that approach, which is no longer a license per seat kind of model, which ends up being very, very different.
Okay, got it. Well, that is very different. Okay, good. I like that. I think this industry needs different. So very good, very good. Okay, so, when you're talking about the problem that you're trying to solve, okay, I get that you're trying to solve automation, right? Let's transfer over to a real-world engineer, Ben. When you're designing electronics, right, where do you feel you need automation to kind of step in? Where do you think automation will save you time?
It promises to save time in a lot of ways that doesn't.
Okay.
Let me start with the iconoclastic statement. I'll give you one really good example. And this is not to say I don't appreciate the tools that EDA companies have given us and even part vendors say. But bomb scrubbing is a great example. So I think this is another difference of where the incumbent players in the industry are really focusing on some of the more administrative tasks that engineers would rather not do. And that's a good thing.
Right.
They should be doing that.
Right.
I still get angry.
Nice.
This is a strong word, but I get, maybe a better word is, I still get frustrated even with really great tools with data feeds from IHS Market or Silicon Expert. These are wonderful things to have. I still get annoyed with bomb scrubbing.
I agree.
So I'm waiting for, and I believe those are the areas companies, existing established EDA vendors in the market are actually looking at those things. That's a good thing, right? What I like about what Quilter's doing, what we're doing is on the actual layout side and the placement side. If hardware design engineers are really actually honest with themselves, they spend an inordinate amount of time. Like if they were actually to log or track minute by minute how much time they spend just sitting thinking about something while they're gazing at it, about where to place a bypass cap near a BGA ball, and then figuring out, I need to rotate it 45 degrees and flip it to the other side. I need it. Will it? And then they have, their mind is full of doubts about, am I doing this right? Will this be manufacturable? And this is why we have certification programs and all this stuff, which is really great. And there's a lot of great designers out there who can do these things, and it takes a long time. I really see Quilter and similar technology, and what I want as a designer is to spend more of my time on the creative task of solving a technical problem by doing engineering a new product. And then some of those things that add up to be huge time wasters if I think about it. And this is also why people want to use things like design reuse, because they know they put so many tens of hours into perfecting the fan out of that particular FPGA or that particular SoC, and now they're familiar with that, and they're familiar with the bypass cap array that they put under it, and all the clearances and everything, and the layer stack that they had to design to make it work and to pass EMI and have good signal integrity and power integrity. So that's all of that just there is such a huge amount of time for an engineer or an engineering team. It's often a team that it's like, okay, now we know that works. We're going to reuse that as much as we can. Don't muck with it. But then that chip is no longer available in 6 months or 12 months, and so new designs can't be using that anymore. So it's back to the starting point. So it's all of that iterative type stuff, and this is why physics is so important to this as part of the feedback loop too, because at the end of the day, it's every new product is unique, and the only way to know it's going to work before spending tons of money and measuring and testing and bringing things up is simulation, really.
Deadlines creeping up like a bad horror movie? Don't let your project turn into a nightmare on PCB Street. At Sierra Circuit, we'll get your boards fabricated faster than you can say impedance mismatch. High quality, lightning speed, check us out at protoexpress.com and meet your deadline.
So I don't know if I answered that very succinctly, but that's where I, as a designer, I want help with those little tasks of design, like bypass cap detection and placement. Even at DesignCon this year, we're up here for DesignCon, basically. One of the best papers I saw was a new algorithm. I haven't tested it myself to see that it really works, but if the presentation was truthful, it was very clever. It was a reinforcement learning method for placing bypass caps under a BGA. Like, I want that in my solution set. And not only did it place, but because the algorithm uses a first order approximation of power distribution network impedance, can actually, while it's at it, say, well, you don't need this many caps. You can take some off. That's really helpful.
That is helpful. That's amazing. Wow, we're really entering in a good age. That sounds fantastic. Yeah, I think, I think it's amazing what I'm hearing and the direction and, the idea of where the true north that you're marching towards makes perfect sense to me. And I think there is a lot of engineers that would be super happy to have a solution like this. That's great. Okay, so the big talk. So how will AI fundamentally transform, I guess, design? That's what we're talking about, right? So you think automation is it?
I think when you think about automation, is certainly going to be a piece, right? And if I can paint a case for the biggest impact that could have, then I'd like to make an analogy for it, right? The analogy I sometimes come back to when thinking about Quilter as a product is to draw an analogy to software design, right? So I kind of loosely think of a schematic as writing code, or maybe like Verilog or VHDL, if you will. And I loosely think of doing a layout as compiling your code, right? Where you're basically just trying to not screw up the schematic. That's really the job. Just don't screw up the schematic.
I like it.
Right? And, obviously to us as electrical engineers, it's like, okay, yeah, layout is very important and it takes a lot of time and a lot of care, and you review it carefully. That's all good and true. But that used to be the case for software. Like, people used to compile code by hand. Then automated compilers started to come out. People didn't trust them. They weren't as efficient. They were 10 times slower in the code they produced and all that stuff. And today, to compile your code by hand would be insane, right? Like, would we have a web browser? Would we have an operating system?
That's a university exercise for undergrads to torture them.
Right. Yeah. Or, I mean, obviously there's some like ridiculously intense use cases where, you have to do it. But yeah, it's 0.0001% of use cases out there, right? So the thing that inspires me about automation and kind of solving this kind of problem is like, well, what happens when you invent a compiler for electronics? What happens when it goes from a 3-month difficult task to a 10-second thing, right? It's not just that it got done. It's, okay, what does that imply? How many more iterations can you do? What different designs can you explore? And so on and so on and so forth. But I think that's not the only thing that AI does, is just like automate a workflow, right? The other big kind of conversation we see at DesignCon, and has certainly been in the literature for a half decade now, is speeding up simulation results. And that's super, super exciting, right? So the idea is that these neural networks are, for my working model, I think of them as interpolative databases. And what they effectively do is they have seen a lot of simulations of a certain type, and when they see a new case, they say, okay, well, here's what's likely to happen in this case. And so now you get a simulation not in a month's time or a week's time for like some computational fluid dynamics, but in a second. And how does that change what you do? Okay, if you can run a model once a second versus once a week, you can play a lot more with the aerodynamics of your situation.
Okay, let's dive a little deep into that. I think you said some words I didn't quite understand. So what's an interpolative database? Or you can say it properly.
Yeah. So one of the things that I have a little pet peeve about is like, the industry has kind of made AI into this thing of like, oh, it's this magical brain that like knows things and figures things out, and like it's like we've put a brain into a computer and it's like gonna like, I don't know, take over the world and be a Terminator or something. And like the thing is when you study how these systems work, like the kind of black magic goes away, right? And so the simplest way to imagine how a neural network works under the hood is to go back to like for example, basic linear regression, right? Like certainly everybody in school has had to take like a bunch of data points on an XY grid, fit a line to it, find the like y equals mx plus b equation. Once you find a good m and a good b that fits that line, then you've got a model, and then you can use something with that model. The only real difference between that and a neural network is that the model is not linear, and that it has not 2 parameters, but 100 billion parameters, right? So, okay, so you have this really complicated function that like fits data, just like a line fits a bunch of data on an XY plot. What good is that, right? And so that's where I like to use that work in term interpolative database, right? What that y equals mx plus b line does is it represents for you all the data points that you fit it to, but in a very simple format of y equals mx plus b, and then you can choose some point on that line and see what the correlation is. The neural net does the same thing, just for much higher dimensional data. So taking it to a simulation, it's like, okay, instead of y equals mx plus b, it's an entire field around an entire car of all the airflow that's happening around it.
Yeah.
And you've seen trillion or maybe billions or millions of those cases. You've fit a big function to kind of approximate all of them, and now you can find cases that look really, really, really similar to the stuff that you've seen in that model before, and then for that reason predict what the simulation might do.
Interesting.
Yeah, like I kind of liken it, and this is a very flawed mental model, but what it really comes down to is like, you could hit a tennis ball with a tennis racket at a certain force with your tennis racket with the strings at a certain tension, and you could model that whole system, right? You could do it analytically with mathematics, and a physicist would want to start there and use closed form partial differential equations, and you end up with what essentially becomes a solver that's something that iterates, and you have to do numerical methods and use a lot of computing power. And so this is simulation up to this point with, say, electromagnetics. It's the same kind of thing. Or you can train a human to hit the tennis ball, and they practice 1 million times, and they become really good at tennis, right? And AI is essentially, way back when Marvin Minsky and others in the 50s were starting to realize, we could model the way human neurology works in software using this thing called a neural network. And it's taking that thing and finding ways to train it so that it's equivalent to training a tennis player to hit the ball. Now, the tennis player is not doing math in their head. They're not consciously playing with equations, right? Because if they were, they'd just stop and have to think the whole time, right? And this is where we're at with things like electromagnetic simulations, why you need massive amounts of compute power, and this is why a traditional field solver may take hours and hours to solve a simple electromagnetics structure, and a well-trained AI model can just recognize where the fields and waves will be. Just like a well-trained electrical engineer who's been doing RF design for many, many years and has already visualized in their own mind can intuitively understand, oh, this structure here is going to have impedance discontinuity at this frequency, and I know because I'm looking at it and I can see roughly the size of it.
Nice.
That's the difference we're talking about. So we're in a way we're modeling or replicating human intuition. I don't know. I might be way off with that analog, but correct me.
I think it's a great analog. I mean, I think the critical point is you need some way to say, I've seen a million simulations. This one looks like something like the average of these three, and these are pretty close. So let me find a point that's kind of like roughly around there and say that's it, right? So like, if you didn't have any training data for the net, it's going to be useless. But if it's seen very similar cases before, then it's likely to predict a roughly accurate result. Mm-hmm. And you shouldn't use that for your ground truth forever, but it's 1,000 times faster. And so you can iterate with it much more quickly and then validate the final result.
So let me ask a layman's question. Mm-hmm. So the simulations that you're talking about, are they the existing simulation softwares that exist or a new simulation way of doing
they're
things?
Existing. Yeah.
Okay.
So there's and this isn't our work. There's papers on this that I'm happy to share. But like, one cool application is you can make trace filters on a PCB, right, of different resonator shapes and so on and so forth. So one group would take a whole bunch of those, parameterize them, run a classic full wave, whether it's FDTD or FEM or method of moments, doesn't matter, and get an S parameter for each of those shapes, and then just train the neural net to reproduce that result. So I don't think that the simulations themselves are being updated from the ground truth. It's that you now have a mechanism to approximate them very accurately, 3 orders of magnitude faster.
Okay.
3 orders of magnitude faster is exciting to me.
Yeah.
It's like,
oh yeah.
And it's think about it. The world's concerned about things like power consumption with all the model training going on. And yeah, it takes a lot of compute power, but actually once you have a good model, you're using significantly less power than a traditional simulation with iterative, numerical methods. So I think ultimately it's also better for power consumption.
That's a good insight. I didn't think about that. That's good. Very nice. Okay, so we'll probably cut this part, but I still need to understand a little bit more. So a simulation right now. So your platform doesn't have simulation in it, right?
In short, no.
In short, no. Okay. And then, so the scope of what you're doing right now today is automation. That's my understanding so far. Is that right? Okay. But this concept that you talked about of, using physics and simulation and all that, you'll be leaning on what to incorporate that into your automation?
Sure.
Just break it down for me. I'm not...
Yeah. So let me talk you through kind of like the steps as we see them.
Yeah,
right?
please.
So when you start doing board designs, right, before it's even worthwhile to think about simulations, the first question is can you even complete the board? Right. Yeah. Can you get all the components placed? Can you get everything routed to 100%? Can it meet manufacturing standards with clearances and trace thicknesses, so on and so forth?
Yeah.
And this is one of the surprising things, honestly, is people underestimate how difficult that is. Right. Like a human could sit down with a 30,000 wire PCB and work on it for a couple months, and they'll finish it. They'll get it done. Computers have struggled with that, right? Every autorouter of old has struggled with that, and even today's approaches struggle with it. It's just not possible, right? So And okay, even if you got something that can just barely solve that kind of board, okay, now you start introducing physics on top of that. It's likely the one that it produced is not going to pass. Now you have to be able to generate lots of different ways to solve it that then meet all those physics constraints. So step one is to be able to solve just a geometry problem, but solve it really well, right? Solve it where it's always hitting 100%. It's giving you a lot of ability to try it this way, to try it that way, to try this set of traces here and try the power traces here and so on and so forth. And only once you have that nailed down does it make sense to then further constrain it with the physics, right? So most of our research internally is happening on that problem, right? How do we get to, like at this point, our best result is a PCB with a BGA on it that's about 5,000 wires that we can hit 100% on and can be manufactured and meet all the tolerances, right? But we have to go much higher than that over time. Now, the next step, as we start tackling, practical use cases, because you have to do the physics to do the practical use, no question about it. I see kind of 3 levels that we can approach with. In truth, like most PCB designs, not the kind of more sophisticated ones that are super high speed and RF and all that stuff, but most just simple PCB designs out there, people don't do simulations, right? Like PCB designers have developed lots of shorthands that basically conservatively guarantee that the simulations would pass if you had run them, right? So things like the 3 widths rule, for example, and like good grounding strategies in your stack up and like things like that, right? Okay, so that is basically just taking what you would have learned from simulation and reducing it into geometric constraints, right? And that's great. That's where Quilter's at today. So if you go to Quilter and you tell it, hey, I have bypass caps and I have a differential pair and I have, all these different things and I have a high current net, that's effectively what it's going to do. Is it's going to reduce it into a bunch of geometric constraints that encode those conservatively. Level 2, in my opinion, is let's start using fast approximations, right? So let's start using like quasi-static approximations, and those kinds of solvers that can give us mutual inductance or capacitance or whatever else on these traces, and then use that result that works in a certain frequency range, but not at the super high frequency ranges. And then the third level would be full wave, right? Like actually do a full FEM or FDTD solver that leaves no approximations on the table, gets you the true ground truth. And that's really the golden signal you would want to train over time. And when we started Quilter, I made the mistake of thinking to start there first, right? So I trained as a physics undergrad, and I was like, okay, well, let's just go straight to the Maxwell equation solution and just use that. Obviously, it's way too slow to do this kind of iteration with. So that's why it's there, but we put it on the shelf for now, and we're going to work up through these levels instead.
Okay, great. Very nice. Good. I'm glad you chalked that out. That was actually very informative. So thank you for that. Okay, so let's go to the off PCB questions. Is that okay?
Sure.
All right, so if you could have anything, Ben, automated in your life with AI, what would that be?
Probably my children. I say that jokingly. I do love them, and I like their individuality. No, what I outside of the PCB realm, what I could really use, and I kind of honestly expected it to exist already, but it's, as far as I can tell, it does not, is a really excellent personal assistant. I have an extremely busy life with a lot of moving parts and things I can't necessarily keep my hands on at all times, and I have to constantly make those trade-offs of what's most important. And I know every time I do that, something else that's actually also really, really important is being dropped. And so, it's kind of a meme going around the social media too right now. It's like, wait, AI is writing all these songs now so I can do my dishes? What the hell? Like, it's meant to do my dishes so I can play guitar. And that's basically what sums it up. It's like, I want that home automation. It can't come soon enough for me to keep tabs on my finances and do all that stuff that I honestly hate and wish I didn't have to do.
Nice, I like it.
And it's not to be lazy, it's to be able to focus what on what I'm naturally passionate about and good at,
Absolutely. No, I can totally relate to that, and I'm sure everyone can. Like, someone close to me said, being an adult is basically doing everything that you hate. I was like, oh, that's very morbid. Well, but I like the way you phrased it, right? Like, just offload, have a good personal assistant, automate the things that you just don't want to do, right? I love that. That's great.
And also that, frankly, I'm flawed at because they're not my favorite things. I'm going to cut corners. The AI is actually more likely to be thorough and careful to make sure I do things correct and don't cheat.
Like self-driving?
Yeah, that might be one of them. It'll actually obey the speed limit. I'm not saying I don't. Imagine how peaceful the world would be if everybody obeyed the speed limit and indicated when they changed lanes.
Oh my God. I like how everyone's like, I have a very big insight. AI is going to drive safer than humans. What, really? That's a very low bar. So,
Yeah.
Good insight. Oh, and also a low bar. AI is going to design better circuit boards than engineers. Oh, no. Okay, that was a bad joke. Sorry. I know it's hard to design a circuit board. Okay, so what would you like, Sergiy, automated in your life by AI?
I mean, I'm in a similar boat, but I would take the robotics spin on that, to be honest.
Okay.
I have 2 little kids.
Okay.
My daughter's almost 3. My son is 1.5 years. And what that means is while my wife gets to play with them, I'm chasing and cleaning up and behind them everywhere. But legitimately, I think for me, that's like the thing that I really want to see over the next 10 years is I think we have all of the mechatronics, the battery density, the manipulators that we need for robotics to take off. We don't have the software. And I think it's about to happen. I think it's about to happen that like you could imagine it cleaning stuff up and organizing things and maybe doing your dishes or your laundry or whatever else. Maybe I'm optimistic, but that's what I'd love to see.
Well, it's going to happen soon, according to Elon, right? Okay, so another off PCB question. But it doesn't seem to have to be an off PCB answer. What talent do you have that you'd like to share? Go ahead if you want to go first. What talent do you have that
I don't know if it's a talent necessarily. I'm not particularly good at it, but
it could be anything.
It could be anything. Yeah. Well, one thing people tend to be surprised when I say this is I practice Muay Thai and Krav Maga, which is super fun. I'm not very talented at it.
You have to educate me what that is. Sorry.
It's fighting.
Fighting. Okay.
Yeah. I apparently like punching and getting punched for fun.
Okay, nice. That's good. No, it's a good. Okay, how about you, Ben?
That's why he's such an enthusiastic staff, and why we're all remote workers. No, he's great. But you told me I wasn't allowed to say it.
You can say anything you want.
What talents do I have that people may not know about me?
Yeah.
Now I'm really stuck. That used to be an easy question to answer. Most people in this industry have seen me around a bit because of my time at Altium and Autodesk, and they know, like I always talk about music, so they know about that. So that doesn't qualify. But I will say this, one thing that probably would come across as a surprise is I have had some involvement with musical theatre.
Okay, that is a surprise.
And not this year because I was too busy and there was too much going on. It's a huge commitment, so I don't really get to do it much at all. But in late 2022, 2023, Christmas season, I was involved in a production about Scrooge, and I got to sing. I had a solo part singing as Scrooge's father from his past. He goes back in time and has the ghosts of Christmas past and has all this trauma going on. So that was really extraordinarily fun. And the cool thing about that particular musical, the people that put it together, it was actually essentially covers of all 80s and 90s music. So songs that are well known, but they selected just the exact right pieces of each of the songs to tell the story. So it was actually super cool.
Sounds super cool. That's great. I'm going to switch to true or false. And so this, think of it as, not just Quilter, but like the whole industry at large, if that's okay. And I guess we'll start, go there. Is that fine?
Sounds good.
All right, so Ben, true or false, AI tools can handle 100% of design challenges without any human input.
Absolutely not.
Okay, false. All right. I think that was an easy one. Okay, number 2, AI eliminates the need for design rule checks.
False.
Oh, really?
Yeah.
Okay. Can you dive? Sorry, this is not a rapid round. Can you talk about
you wanna
that?
elaborate.
Yeah, elaborate. Because if AI can't do rule checks, please explain. I'm not the AI expert. You
Sure.
go for it.
Sure. So suppose for a minute that we took a neural network and asked it to just produce a board, like give me all the traces, give me all the copper,
Mm-hmm.
and then we trusted it.
Mm-hmm.
That probably wouldn't go well.
Right.
Because AI, these are by definition statistical models. They are not guaranteed to be 100% right by any chance. And especially in something as complicated as the board, you basically have near certainty that something's not going to be quite right. So the way, or at least the way that we think about making sure that the board is actually correct and is not up to chance, is you enforce the design rules on it rigidly. And when I say design rules, I'm talking about like what's the fab's minimum trace size, minimum clearance, things of that, like separation to the board boundary, things of that nature. And so what you're giving the AI the statistical freedom over is, okay, we have these rigid rules that must be met, that will be calculated with a classic CPU or GPU in a classic way. The freedom that I have as a neural network is, how do I satisfy them? Do I put all my traces this way or do I put them all that way? And I try to put them this way and it turns out, nope, like my traces collide with each other or violate clearance. And if I split them up, maybe they don't, right? So I think that, especially in reinforcement learning, the reward is typically calculated in a non-neural net kind of way, in a rigid way, that is a yes or no Boolean kind of answer. But then how you try to meet that reward and maximize it, that's what happens statistically. So I think that we should keep design rules, and I think we should keep them rigid, and I think we should run all of our outputs against them to prove that the statistics found a solution to all of them.
Nice. That's a good answer. Thank you. Okay, next one. Adopting AI tools, Ben, makes PCB design faster, but sacrifices the art and creativity.
That is true to an extent.
Okay.
There's a lot of talk and lingo in our industry right now about shifting left, though. And I think by doing things faster and in a what ultimately will be a correct way, it's the intention isn't to remove creativity, it's to shift it to a different stage and allow people to be creative in a more focused way in a different area. AI doesn't know what I want for dinner, but it can make it if I can tell it what I want, and then I can start adding a twist, right? I can have it make me a jambalaya, but I can say, but I want you to change the recipe in these ways, right? So I'm still adding my own influence to that whole process. And look, this is a concern for the artisan PCB designers, and I am actually one of those people. I really find a state of flow laying out a board and doing it by hand, and I still do that in a lot of cases. And I think it's going to be quite some time before the need for that disappears altogether, right? It will happen, but people will still, there's nothing stopping. Look, I can use DALL-E to create new and unique and very cool looking graphics. And I'm a DALL-E user, I'm a ChatGPT user. And I like the results, but I also still like to get pen on paper sometimes, and that's my creative freedom to do it. I think it's just going to change the reason why people do things. I'm doing it myself because it's like, it reminds me of an old movie with Sylvester Stallone, Demolition Man, where there's like the cop, the protagonist's girlfriend in the movie was a policewoman, and the police car was always self-driving, and she's like, no, I want to drive today, and a steering wheel pops out, and she's like, oh. It's going to be like that. But again, like the purpose of technology in every revolution, in every evolution of human technology that we've had all throughout history, yeah, it's changed the way people work. It's changed what people do for a living, but it's enabled so much more.
Yeah.
And so, people need to look at this with a growth mindset.
Yeah, absolutely. Sierra Circuits has been working very hard for electrical engineers and PCB designers like yourself on our engineering tools. These are engineering tools to help you design faster. We want to reduce your design time and get the design right the first time. So our top tools on our website, number one is the PCB Stack Up Planner. Knowing that you have a good stack up right away for your design. Number two is the bomb checker. It'll do basic scrubbing, make sure your ref deses are good, your MPNs are good, the MPN matches the description. All these are amazing features of the bomb checker. We also have an impedance tool, which is based on Maxwell's equations. And these are all for free for the PCB designer and electrical engineer. Please go check them out. It's all for you. Okay, next one. AI can automatically optimize PCB layouts for better performance and efficiency. Sergiy. You want me to say it again?
No, I got the question, but I want to say both answers.
Sure.
I think, I'll use the classic PCB design answer. It depends.
Okay, it depends.
But in truth, right, like there are certainly designs today that I can't even come close to touching,
Okay.
right? Like you look at a latest NVIDIA video card or a server card or something like that, or some like sophisticated radar board, no chance. There's not any AI that is going to, not us, not anybody else, that's going to actually outperform a human today. Not happening. It will come, but not today, right? But are there cases where it could find something interesting? I think that's been shown over decades. In limited, focused, specific areas, it's possible. But it's certainly not generally true.
Okay. So, great answer.
Great answer.
Thank you.
It depends.
It depends. Okay, next one. AI can predict potential, I like this one, potential manufacturing issues in a PCB design before it goes into production. Any one of you would like to answer that one?
It could certainly be put to that use and should be.
I agree it should be. Being a manufacturer, I agree.
It's not a feature of Quilter today,
Yeah.
but I can definitely see there are companies actually in this space. We don't compete with them, but they're people we know who are working on these kinds of problems as well with AI. So it's a different problem set they're focusing on. I don't know how far along they are in the process or how public it all is, so I can't really say who I'm thinking of, but it is definitely something that's being worked on, and I
Good.
can expect to see some results pretty soon.
Great. That's
Yeah.
very nice. Yeah, I think that sounds fantastic. I'd be so happy as a manufacturer.
It's not just manufacturing defects. It's like that whole front end of the design process, and it starts even with the electrical engineering at the schematic level. And there have been tools already, but then they're not AI based. They're more like traditional design rule, like checklist based tools. But they will warn users of things they may have done wrong, even at the schematic level. Like for many years, Altium and OrCAD and other similar like front end entry tools have had basic electrical rule checking. Like you can't connect two output pins together unless you manually override that, because it's like you got conflicting driving sources. And I say to the schematic, no, dummy, like they're working in unison to double the output power. But I have to tell it that. So, I think those things are going to improve immensely.
Okay, good. Very good. AI is going to be used to assist with component selection, and I'll stop there.
Oh, I think that's objectively true. I mean, again, not a Quilter application, but plug for circuit mind and probably Celis would be another one where they're doing exactly that, right? Where you, instead of drawing the schematic, every component at a time, you draw a block diagram of I want a microprocessor, a power supply, a sensor of a certain type, and it'll go and find the best components for that. I think that's absolutely happening today.
So question number 1, what's the most unexpected layout that your AI tool has done so far?
I want to say that, and I kind of already knew this, so for me it's not like super insight, but it kind of is, because I've been over, like most PCB or hardware design engineers, over-engineering things for a long time.
Okay.
And one of those classic cases is the power distribution and placement of bypass caps. And I recently did not a super complicated design, a microcontroller board, and Quilter did a fine job at rapidly finishing it. And I had the boards made, assembled, and they just worked. But the PDN looked like something a human would never have done. There's a 1.1 volt core trace to the dual core CPU inside the microcontroller. The bypass caps were down here. Now the current version of Quilter would put the bypass caps right next to the pin, but this was before we released that capability. So they were a little further away, and the trace width was calculated based on specified maximum current that wasn't super high. So the trace was actually reasonably narrow, about 6 mils. And I'm like, heck, if I measured that with a good probe, I might see a lot of bouncing around as the microcontroller's code is executing and the load is adjusting. But actually everything just worked flawlessly. And it's just that same old thing, like, there are things you can get away with in design, and it takes me back to all the conversations I've had about older tech, even before PCBs, when big systems were built with wire wrap, and actually in some cases they worked faster and had better signal integrity because they had a point-to-point silver wire going in a straight line, or as close to a straight line as it could, across the back of some big board. And it's like, it just reminded me, there's a lot you can get away with if you're not trying to do anything too, like, ridiculously fast or advanced. And it reminded me again that, like, probably 90% of the boards that people need to make in this world aren't like cutting edge by any stretch.
Right. Very true. Okay, next question. AI versus humans in PCB design. What do humans still do better and will do better for a long time?
I mean, I think that most cutting-edge designs is where that's going to stay the case, right? Like, humans define the ultimate frontier today of, like, what's the fastest board you could do, what's the densest board you could do, smallest board you can do. I think it's going to take a while before it catches up. I think it's just that simple.
Okay. Biggest misconception about AI in PCB design?
I think probably the one we get the most is people thinking that it should be trained on human data, or that it would be trained on human data. Every single time we get that question.
Got that, yeah.
Because it's intuitive, right? It's a reasonable way to kind of approach the problem on the surface. But I think most people just aren't aware that there are other ways to go about it that might make more sense. So I'd say that's a pretty common misconception.
Yeah, no, I like your approach. I think it's definitely the right approach. As I've spoken to many experts, I would think they would agree with you as well. No, that's great. So, and I just want to, kind of talk about for a second, like, basically when I hear you talking and, like, automating and, what can a human now focus on that's more interesting or more important? To me, it just seems like there's going to be even a bigger boom in hardware. Like,
Right.
Hardware is going to be everywhere.
Right.
Because at some point, everyone will be able to make hardware.
That's exactly it. I agree. I think as we've seen, even just with 3D printers, like mass customization, the concept that many new inventions are going to be enabled where it doesn't require anything that's like super cutting edge as far as signal integrity. But the person who has the idea hasn't gone through school to have all the electrical engineering training, but they can get enough that they can get something off the ground and do it quickly, and then maybe get a patent or protect their idea, but then get help, get funding to commercialize it or whatever. It's going, or even just on the individual level, I can see a world in the future where I can get home to my house and realize I have a particular problem and there's a practical solution if I just had a little device that did X. Like even just the other day, I'm like, I want a really awesome loud alarm clock which you can only turn off by going to the opposite end of the house and going through a particular ritual to make it turn off. Because, you know, certain members of the household will not get out of bed otherwise.
Well, that's very specific.
There's the next Quilter project, huh?
It probably will be. Yeah. It's on the list.
All right.
I think that's fantastic because, you know, like, you know, the hardware world has been very filled with hardware people and hardware engineers. But what I'm taking away from this is, you know, Quilter can and is making hardware accessible, and other AI companies, I guess, in the industry, they're making hardware accessible to people who might not, you know, venture down this road, right? They're too like, God, I don't know nothing, right? I think that's fantastic.
Mm-hmm.
Yeah, we had a really good case study that we published, I don't know, 3 or 4 months ago with a mechanical engineer who has a small side business tuning car engines, right? And so he sells a product to basically hook up to a ODB port of BMWs and then be able to tune them, which is super fun. But no real electronics experience, right? And so he was out to go like, okay, let me help find an electrical engineer and somebody I can explain the idea to and build it and so on and so forth. And was like, hey, I use ChatGPT to help me write code and firmware for these things. Like, is there something like that for hardware? And Quilter came up and he got like 30 or 40 iterations done with us in a matter of a couple of weeks. Got a product out there and that's it. And it's selling and it's working and he's using it and so on and so forth. And I think that's a really cool story, right? Of like somebody's got an idea and they can go from that idea to a working prototype really, really, really quickly. I think it's huge. I mean, we saw this with. Software evolved from like you have to be able to write like assembly to like C to something like Python, which now like a lot more engineers and scientists can use, to now you can ask ChatGPT to write it for you and it works and you can build a whole website or a whole product with natural language, right? I think hardware will follow in the same steps and just increase by an order of magnitude the number of people who would dare to go and build a board. That's awesome. That should happen.
That's going to be great. I look forward to that.
It's great for Sierra. It's going to be a lot more customers.
A lot more people like, hey, how do you make a circuit board?
Or can you make this?
Can you make this?
ChatGPT wrote the code. Quilter did the board layout for me. Can you manufacture it?
Mm-hmm.
That's nice. I like that. Yes, it does make a nice future for Sierra. But it's going to grow an even bigger market, right? It's a huge market.
Yeah. So
and it's going to grow the market.
So I say, like, people have to approach change. Look, we should always have a healthy level of uncertainty. Like, fear may not be the right word, but a certain degree of, I'm not sure what's going to happen next. This is interesting and a little bit scary, but that's a good thing.
Right.
Because it keeps us on our toes and observant. And all humans need to remain observant. Unfortunately, many don't. But yeah, I mean, this is another enabler.
Have you thought about that as the market focus? Like not focusing on complex designs and not focusing on, you know, pinning out like crazy BGAs or whatnot, but like really going after the, people who are not electrical engineers?
Honestly, yes.
Have you thought about that? Because
yeah.
I guarantee like a Cadence is not thinking in that way, right?
No, 100%.
Right.
So for one, obviously we have an open beta, and of the thousands of users who come and use it, a lot of them are in that category. And like hobbyists and people who are playing with stuff at home is great. And but the difficult part of making a business is that those people don't typically have a big budget to spend on their hobby projects, right?
Yeah.
Now this still can be made a business if you go after like what we've termed internally as sort of adjacent engineers. So I'll give you some kind of examples, right? Actually, myself as a background from SpaceX. So we did radiation effects on all the electronics on Falcon 9, Falcon Heavy, Starlink, all those systems, Dragon. A part of what it meant is we would need to take either parts or sub-circuits or even entire boards and go smash them with a bunch of protons physically. And for that, you build a lot of boards. But those boards are never going to fly. They're never going to be bolted to a rocket. You're never going to need to pass EMI testing with them. Like, you build 3 of them. If the chip works for the duration of the test, great. You get your test data. After that, you can discard the board because the test data is what you care about. Now, in that case, I'm really a test engineer who needs a report to decide, is this chip going to fly or is the chip not going to fly, right? And the board requirement for that reason is actually quite loose. Like, it can be sparse, it can be more layers than you might otherwise design, it can be more expensive because you're not going to do it in volume, so on and so forth. And so Quilter is a perfect use case for stuff like that. And so the most successful kind of commercial use cases that we're coming across are not the super intense BGA operating at highest frequency with DDR7 or whatever else is coming. It's really like, hey, like, I need a microcontroller to drive a robotic arm to automate something in the factory, or I just need something to throw firmware on there to see how we're going to write code for this thing ahead of our actual production design, and so on and so forth. So I think that's the right place to start. Those are the boards we can handle. Those are the boards that have a lot of value. And then those engineers are not super skilled at Altium or Cadence or whatever else. And for them, they don't even want to do this task. They want to go get their test data. They want to write their firmware. They want to get the automation solved or whatever else. So I think it's a perfect place to start. And then from there, you slowly increase the onion layers of what you can tackle and go up the complexity chain.
Nice, I like it.
The complexity will come.
100%.
I mean, there's already people... there's already talent looking into different ways of leveraging AI to solve some of those harder problems. So you just have to have that growth. This is what I was trying to say before. You have to come at this with a growth mindset, and that's something like old school engineers or traditional EDAs are always going to hold on to skepticism and the way we've always done it, or we can't cannibalize our own sales pipelines or whatever. And it's like, maybe they will act that way. Maybe they will adapt. We'll see. Companies live and die by this. And
it's definitely a big point in the industry. So
yeah,
there will be some people taking advantage of it and people who kind of miss the boat. Yeah, I see that. It's good. Very exciting. So another question, right? So right now when I go on Twitter and YouTube, everyone says, the people with the most compute are going to win the LLM model race, right? Who's going to have the best brain? Is it Google? Is it DeepSeek? Is it, Yo-Yo? Whoever, right? Mm-hmm. And it's all about the compute. Hence, NVIDIA, is like a crazy, hugely valued company right now in like a year. So what's the race in your space? Because there's other AI PCB design companies, right? There is. I don't know who they are, but there is. I've seen them around. What is the race for you guys?
So I think as far as there's honestly more of a diversity of which exact problem you solve than there is of people going after exactly the same problem. Right?
Okay.
So obviously we've alluded to the big players in the space, and they have an approach to layout that's a bit different than ours, and we've discussed that. There is definitely other companies. I mean, we talked a little bit about Circuit Mind and Celis, right? But they're focused on schematic. not on layout, which is great, but just a totally different part of it. There's companies like JetX and Autopile that are making bets on just hardware definition languages for schematic as opposed to graphical schematics, and then what that implies. Surely there's probably more stuff on like the procurement and BOM side that I'm not currently thinking of.
Yeah.
There's with Dempaflux on EMI, verification side of things. So I think an important question not to forget is this whole ecosystem of workflow has a lot of different pieces, right? And a lot of these AI companies, it's not like we're all going after all of this problem. Mostly, we're actually all focused on very, very, very different things. So that's obviously a big important question, or even before you get to compute. And compute is important, no doubt about it. But there's how you use it is also important, right? We're not at the point today with AI where it's just you download AI, you say AI.train, you throw compute dollars into it, and magic happens. If that were the case, OpenAI wouldn't be paying $1 billion a year to their best engineers, right? There is a skill to what is the right data, what is the right approach, what is the algorithm you use, what model do you use, and it can make orders of magnitude of difference in terms of the compute required to solve the same task. So compute is a part of the equation, but it is not the only variable. It's just the most discussed variable.
Yeah,
Okay.
there are other variables too, like baggage. I mean, if I already had 100,000 customers or users that I've built up for decades, I'm much more likely to ask them exactly what they want tomorrow, and either build something completely different quietly without really letting them know what's going on. So the skunkworks approach, or just focus on improving what they do day to day incrementally, which is a good thing to do, but it's just a completely different approach. The nice thing about being part of Quilter is we get to do things pretty much from scratch. We can solve problems and do things a completely different way, because we don't have to be afraid of really vocal customers who are going to go campaign against us amongst the user base, you know what I mean, on the forums or whatever. We don't have that baggage. And I'm not saying that what we're doing would be offensive to a lot of existing PCB designers. It might be, but I don't think so. I think, again, if they have that growth mindset, they're going to see that this is the future. And yeah, the results may not look like what they would want today, even if they do work and pass EMI and all of that. The people who come at this with an objective mindset are going to say, yeah, this just makes sense. And we have a clean slate to start from, and that's freedom to build something really different, revolutionary, changing. Revolutionary is a bad word, sorry. It's too buzzy. I'm saying but to really change the idea of what a PCB should be.
Yeah, from first principles. Right?
Exactly. And that's a good thing, to be able to do that and have the freedom to do that.
Yeah, no, I agree with that.
Ever feel like your PCB questions are shouting into the void? Well, guess what? The void finally answers back. Sierra Connect is where engineers like you discuss stack up, layout, and impedance troubles that only make sense to printed circuit bros. Join the cool designer club at sierraconnect.protoexpress.com. We saved you a seat.
Yeah, I think the other thing we didn't talk enough about here is there's so many connections to manufacturing that this unlocks.
Hell yeah.
Please tell me.
Oh, man.
Please explain.
I think that, look, another fun misconception, right? I talk to users sometimes who are you must make this a 2-layer board, right, as an example. Because conventional wisdom is okay, 2-layer board is the cheapest thing, the fastest turnaround, so on and so forth. But in reality, a 4-layer board is barely more expensive and barely slower to design, if at all. Slower to manufacture, if at all. compared to a 2-layer board nowadays.
Well, yeah, and if you don't need blind or buried vias, like it all comes down to, if we can do this with a single lamination cycle, it's going to be fast.
So I think there's like things like that. That's a very basic thing. Like I think most designers overestimate the cost of even the difference in cost between like a 2-layer board and a 4-layer board. But I think there's way more things like that, right? Like we've been, like one of the things that we've been getting excited about, and this is like, you know, a long ways in the future, but it's like, how do we very quickly turn around a 20-layer board, right? How can we do a bunch of lamination cycles in parallel and then do one big one all together? Like what materials does that require and what kind of process might that
You guys
be?
are working on stack ups, right?
Yes,
Yeah.
100%.
Okay.
Exactly.
And if we need to, we'll use exotic conductive
Oh, interesting.
methodologies, but there's all sorts of opportunities. Sorry to.
No, I think just the point is that like
Yeah.
if you can encode into Quilter all of the different possible ways that you might do a stack up and lab cycles and so on and so forth, that becomes an optimization variable. And most electrical engineers and schematic designers aren't aware of like all the different most recent materials and the latest
Definitely not.
technologies. Right. And so now you have this opportunity to bring that to the designer and say, hey, by the way, did you know we could turn this around in 12 hours if we just do it like this? And that'll be a surprise to them, but it's also immensely valuable, right? The reason people come to us is a board that was going to take them 2 weeks now takes an hour. But if the fab takes a week or two, then that value gets ruined. But now what if we can say, hey, we can design what you took to design in 2 weeks in an hour, and then also we found a way to fab it in 24 hours as opposed to in a week. The value is immense. Other things like, for example, imagine hooking up Quilter to your stock, right? So if you're out of some material or you're out of some part even, but you really want the board tomorrow, okay, redesign it with a slightly different material or a slightly different part. You know, like there's like things like that you could do that just make the process of, because what do you really want? You want to go from schematic to board on your desk as quickly as possible and as painlessly as possible. And to design a good layout, you must consider what the manufacturer can do, what their tolerances are, what materials they have in stock, what parts they have in stock, all of that kind of stuff. And that requires a phone call and a negotiation and miscommunication sometimes. And you guys hate it as much as we do when you have to send a board back and say, hey, you didn't meet our specs, right? And that's a delay in the process. And nobody likes that. But if algorithms are aware of what the fab is capable of and are very rigorous, applying the DRCs and being very confident that it's met, and can optimize that for the manufacturer as well as for the schematic side, then we get this common benefit of a really quick turnaround.
So you're still, so in your like code or whatever, however you think about it, so you still have DRC?
100%.
Oh yeah.
Okay, so you're
100%.
designing a DRC system as well.
That's one of the checks that we punish or reward the algorithm with, right? So the way
But the
our,
DRC is, okay, sorry, go ahead.
So if one result gets 100% routed, but the hole to edge clearance doesn't meet, say, Sierra's requirement, that one's punished for that layer stack that we know works with Sierra, for example.
Got it.
and in
Yeah.
general, the
That's interesting.
optimization is like, I have this schematic. Do I need a 10-layer board? Can I do 8 layers? Can I get away with 6? Can I get away with 4? Right? With Quilter, try all of them. Right? And obviously the simpler one will be faster. And so it becomes an optimization variable rather than just a constraint to your design.
I mean, more true on the more complex designs. On the simple ones, 2, 4, 6, 8.
Mm-hmm. One way people are doing this is with the size of the board. Right? So conservatively, if you know it's going to take you a couple of weeks to do a board layout, you make sure the board is big enough that you don't run out of space. Otherwise, you run into a dead end, and you have to go back and spend a whole other week, and that's a disaster as far as schedule is concerned. We see people coming to Quilter and taking 5 different board outlines and uploading them at the same time, even if it's for the same stack up. And then, like, the smallest one, Quilter fails to hit to 100%. The middle one, it hits. And the biggest one, of course, it also hits 100%. And they're like, all right, that's the one we're going with. That's the smallest I could do. So that's another kind of thing that you could do. And that, of course, smaller board size leads to more boards on a panel, leads to, better unit economics and so on and so forth. So there's lots of different ways to kind of play around with this.
I shared with Sergiy, actually, that you turned around 4-layer boards for me in 8 hours.
Yeah.
Mm-hmm.
We do things quickly, yeah.
Yeah. It's like really cool. Very cool.
Do you guys have? If you guys are a source of like finished designs, do you know if your designers are taking that and then building with those designs, or are they just kind of messing around still?
It depends.
It depends.
Some build, some mess around, right?
Okay.
It's in the open beta. People are welcome to try it out, and many people will throw something in and say, "Cool, but not there yet." That's fine. But plenty of people go and manufacture for sure. But the ideal case would be right at Quilter's site. You can just be like, "Yeah, buy it."
Yes.
Right, and that kicks off a PO to you guys, and then you make it, and as fast as possible it arrives on their desk, ideally assembled, and the person can go in and program it and go use that board. Right, that's the dream scenario.
That'd be nice. Yeah, I know Altium tried to do that with Macrofab. I don't know how well that worked out or not. It was right before
Yeah.
Altium.
Yeah,
sold
and
its soul.
PCB-NG and
Does it work for them, or I don't know?
I don't know that anyone's really using that, send to, well, because from Altium 365 you can click send to manufacturing,
Okay.
but all it does is send an email with a link to create a login and get secure access to the release data.
Okay.
And I think they tested it out with Macrofab, and Altium put some investment into Macrofab to help them
Oh, geez.
expand, and they are actually doing really well. They're going great guns. I've run boards through them for full assembly. It's expensive, but they do a good job.
Okay, great.
But I have no insight as to how many people are actually using it, how successful it is. But from what I see, it looks like they're doing pretty good. They're growing.
Okay, good. Good to know.
Yeah.
Yeah, so I don't know. We can talk about that, like a relationship of some sort.
Mm-hmm.
That'd be nice.
Yeah.
We always want more business, more boards
Sure.
to build,
Yeah.
right?
Yeah, and for us, it's where can we point our customers to get it turned around as quickly as possible?
Exactly.
Because the main value we deliver is speed, right? We're not delivering a better design, we're delivering a faster design experience.
Yeah, I picked up on that, and I think that really aligns with what we do.
Right.
Yep.
We sell time,
Right,
right?
exactly. We sell time.
So
Exactly
that
right.
aligns perfectly. So, yeah, we should totally kind of build a business
Yeah,
relationship.
let's go from schematic to board on my desk in 24 hours.
Nice. You might scare people. No, I like
But let's
that.
do it.
No, I love
What kind
it.
of world would that be, right? Like, now I still talk to my friends at SpaceX that are like, all right, 2 weeks in layout and then 2 weeks in fab, and I have to like be on the phone every day to see how it's going and to stay on top of it. And I'm like, man, that
That's
sucks.
not like the industry at all. That doesn't happen.
It boggles my mind how like companies can pipeline work for people in that situation, so that it's like, yeah, you've got that, you've done that, it's gone to fab. Now you're waiting. What are you doing right now? You're not just sitting at your desk doing nothing. Like, you've got to be productive. So what are you doing?
Waiting for my
You're
board.
working on. You can't be working on the next version of that board because you don't know if it works yet or not. Like, what else are you working on?
That's awesome.
It's like just that pipelining of design. I know like there's project managers out there, and that's their skill. They're really good at it, but that whole thing is going to shrink tremendously in the next 3 years.
Mm-hmm.
That's awesome. I love it.
People will be able to work more linearly and not have to task switch mentally between projects. It's going to be great for the engineer to be able to stay focused on one thing and see it through. It's rewarding.
It is.
Mm.
Do you guys fab overnight?
Yeah.
That's what I'm talking about, man.
We
5
do.
o'clock, I submit my board,
Yeah.
finish my schematic, I click a button. Next morning, I show up and it's there. That's what I'm talking about. No time lost. That would be absolutely unbelievable for myself at SpaceX. It would have been, and I'm sure for every designer we talk to, that's like an unimaginable dream at this point. But it's possible.
It sounds possible.
Of course.
Yeah, no, I'm like sold, man. I'm signed up. Yeah,
Let's do
we
it.
should totally do that.
Yeah.
Let's probe it out.
I love it. Yeah, let's do that. Okay, thanks guys. Thank you very much.
you.
Thank you.
That was surreal.